Good morning. I hope I am audible. Please write on the chat box so that I can start our session.
Yes, sir, you are audible.
Thank you. Thank you for your kind response. Thank you. Thank you. Thanks. So, as the time permits, I am Dr. Vivek Tiwari, Assistant Professor in IIITNR Raipur, and the coordinator of this 1 week long FDP on building models through data exploration, pre-processing, and representation. Behalf of the IIITNR Raipur, behalf of all the staff who is really working behind this FDP, welcome you all the participants in this FDP. We are really very much thankful to all of you who have shown their interest in this FDP, and I assure you the journey of this 1 week long FDP is really will be fruitful for you. Before going into the detail, I have received a couple of mails and WhatsApp messages asking some questions about the FDP and the small things. So sometime it will create a lot of confusion. So I will couple of minute I will take to announce some important parts, some important things that as a participant you must be aware about that. So what are those things? Let me discuss about that. The people are asking about the attendance. Since this FDP is sponsored by the Atal scheme that is a part of AICTE, so they have set everything in advance. The attendance of the FDP must be minimum 80% or more than that. First things, please make it clear. How I will conduct the attendance, I will explain. First, we discuss on the criteria they have set. The criteria for the attendance is 80%. Okay, and they have also instructed to conduct a online test or quiz at the end of the FDP, and the quiz, or sometimes we call the test, the minimum marks you have to score is 60%. Okay, these two things are clear. Now pick up one by one. The quiz I will conduct at the end of the FDP, I think 5th of October around 3 or 3:30 p.m. It will be totally based on the MCQ questions. There will be multiple choice questions will be there, and questions will be based on the content will be covered by doing this FDP by various experts and various invitees are there. So there will not be any question that out of the content, out of the things which will be covered during the FDP, and the question will be totally on the MCQ basis. Now come to the attendance. Many questions are regarding the attendance. So how 80% come? Let me explain. We have 5 days. We have 5 days of FDP. I will float attendance link. I will float attendance link that is a Google form. It is nothing but attendance link means is a Google form. Okay, it is a Google form, and there will be in a 1 day, means a single day. I'm talking about the methodology. I'm explaining about the attendance. There will be session 1, session 2, session 3. There will be 3 sessions. Okay, so I will share the Google link that will be same for all the 5 days. The link, the attendance link, attendance. I'm talking about. Please be focused over there. I will share the attendance link. Okay, that will be same for all the 5 days. Okay, in a particular day, there are multiple sessions like 3 sessions. I will announce during the talk. During the session, the link is open. By default, link will be closed, and randomly any one of the session in the 1 day the link will be activated, and I will announce it. I will announce during the session, during the talk, the link is enabled, and the whole session the time will be given to you, means 1.5 hour 2 hours will be given to you. During that times you have to fill your attendance, and then the link will be closed. So one thing, attendance link will not be live throughout the morning to evening, throughout all the session. No, the attendance will be activated randomly any one session in a day. During that session, maybe 2 hours, the link will be live and you have to give attendance. After that, attendance link will be closed. So means, what is the meaning of that? Every day you have to give the attendance once, okay, and 5 days attendance like will be there, and you have to score at least 80% attendance. I think that thing is clear about the attendance. Please write in the chat box. I request to participants to be active, to be vigilant. Yeah, thank you. And the quizzing is over. And the last question the people are asking about the certificate. Certificate. Certificate will be issued by directly the AICTE. Okay, so the way you have, thank you. The way you have registered yourself in this FDP through the AICTE Atal portal, the similarly, once the FDP will be over, I will enter your attendance one by one and your quiz marks. So if attendance quiz marks is qualified with the minimum threshold value, automatically AICT will release the certificate to you. The certificate will be available in your AICTE portal, and they might be will be, I don't know about that process. They maybe drop a mail to you, your certificate is ready, like that. Means certificate creation is not in my hand. It is not under my control. If attendance is okay and your marks is okay, once I fill the marks, then that certificate will automatically be developed and created and shared with you. Now about the timing. So once the FDP is over, at least I will take 15 days to fill all the detail of all the participants. So don't uh, hurry about that, or don't worry. Don't expect immediately after the completion of the FDP, the next day you will get the certificate. A lot of calculation, a lot of things at my end, I have to do it. Once I get the time, I will complete it, will upload all the required detail in the Utter portal. Immediately they will release the certificate. So don't be hurry about the certificate. The process is clear. So these are the three type of queries frequently I used to get it, because we used to conduct such kind of many FDP in a month. So these are the main questions where the participant worry about. So these three things are over. Uh, Now go back to the session. So let me open my PPT. Okay, so the thing is, this PPT is visible to everybody.
Yes.
Thank you, thank you. Don't unmute yourself. You just write on the chat box. Okay, so the title purposefully I have taken at the first day of the FDP, and the title is around the introduction of modeling basic terminologies. And you might have observed it is a hands-on. So in the purposefully I have written the red color. It is a hands-on. Uh, One more thing I forget to declare. This is FDP. This robust. The total title I have given the FDP is the robust FDP, robust AI. It is going to be conducted in two separate, completely separate phase. Phase one. This is a phase one. Right now we are conducting. We are involving. There is also a phase two. Phase two. So there is this FDP will be conducted into the two separate parts. So phase one is like first to 1 to 5 October. It is a completely separate one. So it is called beginning or introductory level content will be covered over there. And the advanced topic will be covered in the second part of the FDP. I don't remember the exact date, but maybe it is a February 2022. So one thing, please make it clear, this is the introductory FDP, and we will cover the introductory part, theory, practical, hands-on, and the later the phase 2 part will be basically based on the advanced topics like a deep learning or sentimental analysis and many other topic we will cover in the second phase of the FDP. Both are totally separate. So don't worry about that. Every participant have to attend both the FDP, it's required the certificate. No, both are independently. But the suggestion is that since conducting or attending the part one, you might have developed a basic understanding about this area. So it is better to go for the advanced version. Okay, you need to register separately for that FDP also. So don't think that you become a part of phase one, you automatically become a part of phase two. No, separately through the Atal portal, you have to also register for the phase two. Okay. So the title of the FDP we have taken the introductory part of the AI modeling, model development life cycle. Many things I will cover. It will be going to be hands-on. So like in IIITNR Raipur, we believe on the concept skill first, theory later, and project integrated. So we don't believe on to push up or pour a lot of theoretical content and then go with the lab or implementation. No, from the day one, we start covering small topics and try to explore, try to demonstrate by using the code, by using the implementation, so that the proper understanding the participant can develop. So this session is going to be hands-on. So what are the basic content I have planned for this session is that I will discuss briefly about the model development life cycle, because in the machine learning or deep learning or any kind of learning process, if you are ultimately you need to develop a model like a software development life cycle. I think many of the participants are well aware about the software development life cycle, waterfall model like that. So if your task is given to you to develop a project or a software, you have to follow the some phases, some steps sequentially. So that is called development life cycle. The same way in machine learning, we used to develop a model, and model is not a something that within a second you will get it. You have to follow one sequential path. In between the sequence, there may be iterative phases are there. So what are the is what are the steps that you're supposed to follow to come up with a very good model that I will cover. Basic terminology is that throughout many experts, many invitees are going to be used throughout the next 5 days. And what are those terminology that they assume the participants supposed to know? I will try to cover today. So because they will frequently use those terminologies and they assume you must be aware about that one. So it is my responsibility at the beginning of the FTP to make it aware about all such keywords, terminologies, their meaning, their interpretation in advance to enable you for a better learning. Then I will cover the R installation and data importing very briefly. And don't worry about the terminology R. So in machine learning, basically people are working in the three platform, the Python, R, and MATLAB. At our level, like a faculty level, or now it's also very common with the student level, platform is not a bar, syntax is not a bar. So don't worry about that. If you don't have any exposure about the R, about the Python, about the MATLAB, don't worry about that. So every code, every line, everything I will explain in detail, and I ensure you everything you will understand. So don't worry about the coding or if you don't have that exposure. Or don't try to install R Python at your end, because it is the theme is designed like that way. I will take up all the code, I will take up all the data set, I will demonstrate every line with the concept. You need to sit and understand. and everything will be given to you so that you can practice whenever you have time. So don't go with the parallel. Start opening the R, start writing the code, because you will miss the understanding what the expert will uh, share in between. So the experts and the NYTs are not in my control. Some of them may have a exposure with the Python, so they will explore or they will demonstrate the things by using Python. Some of the expert or resource person may be using the MATLAB. I'm using the R or sometime Python also. So you need to be little bit flexible to understand all those things. Now I will go also will try to cover the data split and attribute conversion, because uh, the modeling or develop the machine learning model, you need to divide your data, you need to split your data into the small segment. Why we need to do it, all things I will cover. How to write the code for all those things, what is attribute, variable, features, how to convert one features to another format, like that I will cover. It's totally hands-on. Rescaling of data I will try to cover, I will try to touch upon if the time permit. It's also hands-on. So everything I will cover with theory with hands-on. That is a content. Going with the head, uh, there is a one word, one separate words the people use commonly to convey the same meaning, like algorithm and model. So you ask yourself, when you talk about like a linear regression, uh, uh, like a CNN, like a KNN, like a decision tree, like a random forest, what is that? Is it algorithm or is it model? So pause for a 10 second and try to think, because many of the time beginner use these two words anonymously to convey the same meaning. They sometimes use I have developed the algorithm, or I have a algorithm, I have a model, like that. So you need to understand what is the technical difference between these two words. These two words are totally different. So you need to understand what is the meaning of that one. So let me start the things. Okay, so that word I hold it down, and I will cover the algorithm and model. So throughout this session. So, so model development life cycle is talking about the task is given to you, the problem is given to you, and you want to solve it through the machine learning. So, in broadly, there are four phases that you need to go through it. Uh, and I assume that the data set is with you and the problem statement is given to you. What is the meaning of that? What a data set is important. Without the data set, machine learning is nothing. So you can't do anything if you don't have data. So like a car without fuel, you might have a crores of cars, but you don't have fuel, you can't move it. Similarly, I assume that data set is given to you, and the problems statement is given to you. Now you can solve that problem by using many of the algorithms. So don't assume that at the day one the problem is fixed, the data is fixed. Similarly, algorithm is also fixed. No, algorithm is a tool. There are many tools. So based on the nature of the data set is given to you, based on the nature of problem statement is given to you, you supposed to be smart to find out the suitable algorithm. It will not come from the day one. Don't think in the 5 days DP you maybe develop that skill to decide the type of algorithms you need to select by seeing the data set and problem statement. It is difficult, but you should supposed to know that is a process. So once first, the algorithm you have to select based on the nature of the problem, based on the nature of the data set. Once algorithm is there, you should go with the training. Training means you need to make your algorithm learn so that it can take decision, it can do something behalf of you. So training is something like a learning and training, both are the same word we using in the context of machine learning. So means it is training is going on, means algorithm is learning through the data. So that is a training process will be there. After the training you will get a model. So model means learned model, and you will expect the model will take the correct decision behalf of the you. So Sometimes the model learn nicely, sometimes because of many problems, the model failed to learn the concept, failed to learn the pattern, failed to learn the hidden trends in the data. So you have to carry or go through the model validation or model evaluation. So you have to validate your model, or you have to evaluate your model, you have to check your model, you have to examine your model. Like you teach a student, then at the time of the semester you used to take the exams. Similarly, model validation means you're checking the model whether it is fulfilling your requirement, your expectation, and in many situations the model is working fine or not. Once it is over, still the sky is the limit. You can improve the model performance, model working, whether in the term of accuracy, whether in the term of time taken, taken by the model, whether in the term of memory requirement of the model. That is called model optimizations. So model optimization is that at the with the limited time is given to you, whatever the base model you have, you can start using that model, but meanwhile you can go with the optimizations to increase the performance. These are the whole process of the FDP, and I will cover some 4 or 5 talk I will take during the FDP. So through the phase one, through the up to the optimization, everything I will cover. I will cover in theoretical part or also demonstrate by using coding. Now the question is that I started with the term algorithm, you see, and ended with the model. So algorithm model, the difference is very much evident if you see the phases. So once you have algorithms, means like a algorithm means what? It is a raw or a sequence of logical statements that can perform some task, but it cannot perform some task. You need to provide, you need to feed the data to the algorithms so that algorithm can learn something. Once the algorithm learn, it become a model. So that is very important distinction you're supposed to understand. Whatever the algorithm is given to that, maybe KNN, maybe a random forest, maybe a naive base, whatever the algorithm you know, you feed the data set. You feed the data set. After the training, it become a model. What the meaning of model? Means algorithm, you feed the data of dogs. So after the training, the algorithm will able to recognize the dog photo. If you feed the photo or image of the dog in the real time, it can predict it is a dog. If you feed the data of cat, it will learn how the cat look like. If you feed the data of horse, it will learn how to horse look like. Algorithm alone can't do it. So alone algorithm is not usable at all. It is useless. It can't do anything for you. But once you feed the data to the algorithms, based on the data, algorithm learn a different concept. If data is dog data, cat data, horse data, anything others data, the algorithm can learn something. So actionable form of the algorithm is called a model. Model can take the action. Action means it can do something. So that is a basic difference between model and the algorithm. So it is written over there like a model is a encapsulation of algorithm and data, you can say. So through the diagram, you can also understand the data you need to feed the algorithms. The algorithm will become a model. Okay. Now, many of the student who are really at the beginning stage, if you ask what exactly happened in the training, they fail to answer. They still think there's something magic happen during the training, and automatically algorithm become intelligent and start taking decision. There is no magic behind that one. It typically mathematics only, total mathematics. There is no magic, there is no any black box. So you feed the data, algorithm automatically will learn something. It is not like that. So some of the terminology I am explaining over there: training data. You feed the training data to the model, to the algorithm, sorry, not a model. Algorithm will having so many parameters. Sometimes we call the hyperparameters. Sometimes we call the coefficient. So these two words the people use very frequently, and many books they are using these two words frequently, like parameter. Sometimes they call the coefficient. So algorithm is simply a mathematical function. So if I say algorithm is not a something, it is a, you can consider the algorithm, machine learning algorithm as a mathematical function. Mathematical function. And mathematical function have so many parameter or so many coefficients sometimes you talk about. So so once you feed the data, ultimate algorithm is estimating the value of parameter, value of coefficient. That is only training. Very one line answer. It is exactly 100% correct way to understand. Learning under the learning, what happened? Only algorithm try to come up with the suitable value of the parameter, the value of the coefficient. That is the only single objective of the training. What is the meaning of that? You can understand with a simple example. Suppose the linear regression I'm talking about, I'm not going into the much detail about what is a linear regression. In the next session or maybe tomorrow I will cover. At least everybody is supposed to know the linear, or somebody is writing I'm not audible. It is clear, it is I'm audible to everybody. Just I have seen a one message. Okay, thank you. So if not, if I'm not audible to someone, please recheck your system setting. Thank you. So what I was talking about, the linear regression is someone, a very simple way you can understand is a line equation, y is equal to mx plus c. So I will cover very detail in that part. So don't worry about that. Tomorrow morning session may be like a linear regression. I think so. So linear regression is like that. B0, B1, X1. So sometime we call it C, sometime we call MX. So Y is the one variable and X is the variable. Variable means that you need to provide. In detail I will cover. These are the coefficient or parameter you can say. If you have a more number of variable, you can extend this equation. I will cover that equation very much detail. Don't worry about that. So this is the algorithm. This is the algorithm y is equal to mx plus c, or the line equation is the algorithm. You feed the data. You feed the data. Means the training process is going on. After the training process, you may come up with y is equal to 10 plus 2.5x. So you have estimated the value of coefficient b0, b1. If there are other coefficient, will be there. So it is a model. So what is the difference? The it is a algorithm is a mathematical equations. They might have a couple of a very few parameters, might have 100,000 of parameters. Like in deep learning, there are thousands of parameters. So because there's so many layers, crores of parameter, lakhs of parameter I have seen. So it is a responsibility of the training process to find out, to estimate the suitable value of parameters or coefficient in that equation, in that algorithm. So that is the magic only. There is a nothing that we can't understand. How the 10 and 2.5 is coming, or that is a part of algorithm working, then I will cover. It is if a linear regression, I will cover how you can mathematically estimate the value of 10 or 2.5, how it came here. That derivation I will cover then that part. So it was the basic understanding about the model and algorithm. Going ahead, so the modeling, sometimes people also using that word modeling. So modeling may be seen in various contexts. Sometimes people use modeling means the algorithms feed the data after the training, whatever the model you receive, it is a modeling. Sometimes people say no, modeling means what is the best model you can give. So it become a very much iterative process. Means you need to apply the data to the model, you need to evaluate it, if it is not fulfilling your requirement, you have to change your data. Change data means you have to transform your data. Don't replace with the data because that is not in your control. So you can do a lot of pre-processing with the data. You try to make your data compatible with the algorithms. You can do a lot of customization with the algorithms. So many things you have to perform in iterative method, that is totally called hit and try. Machine learning is totally hit and try. Please keep that word. That is a thumb rule. There is a no rule that you follow it, you will get the model. No, I will explain through the implementation. Hit and try, hit and try, hit and try, hit and try, hit and try. And after hit and try, the given enough time, whatever the base model you have, sometimes people call this whole process as a modeling. So ultimate modeling means what? Making or developing a model that fulfill your requirement, going through the training, testing, evaluation, optimization process. That is called modeling. So sometimes model development life cycle is also is known as a modeling. So what happened in the modeling or training? So in very briefly I will cover. You see the training data is there. You need to feed the data into the algorithm, that is called training process. Once it is over, you have a model. Once you have a model, you input the data, that is called test data, and your model will predict and try to see whether the given output given by your model is correct or not. So how it happened? It happened by using giving the training and test data. So what is training data? What is the test data? I will cover in this session. So don't worry about that. The whole holistic picture you try to understand. Training is something where model learn. Testing is something whether we see the performance of your model. In the both case, we require the data, because testing cannot be happen without feeding the data. Similarly, training cannot be happen without the data. What is the basic difference between training data and testing data? I will cover. Basic terminology during the training, testing, during the model development is like that. Sometimes we'll talk about what are the features of data, what are the variables of the data, what are the attributes of the data. So in they convey the same meaning. If I say, the data set is giving to you and I'm asking there are 10 features, there are 20 features are not good, features are discriminative features, we need to require more feature, we have to delete some features. So if I using the word in the literature, if they are using the word feature, means same meaning, variable means same meaning, attribute means same meaning. They are most important part of the machine learning, or if I say precisely, is important part of the feature data set is given to you. If the data set don't have any feature, means algorithm cannot learn anything. Feature means what? Feature means it is a property that describe your data, that describe your entity. So for example, if if I can explain like that, suppose you want to predict, suppose all of you are suppose a teacher, you want to predict a student is there, he will get a job or not, he will get a job, yes or no, that you want to predict. Task is given to you as a teacher, you are handling 100 students, and the particular student, I will ask whether the student in the coming placement drive in the fourth year, the student will get job or not. Suppose this question I have asked. So what you need, it you need to know about uh, the 10th and 12th percentage of the student. Similarly, if the student is a BE, he is doing BE, then you need to know first two or 8 semester CGPA, whatever the CGPA available to you, that you will ask. You will ask the type of project the student have done. You may ask, you need what data, type of skill the student have, technical skill, whether the student is expert in R, Python, or any course, any kind of certification student have done, and what is the how well the student is communication. So based on that property, so these are the feature: 10th standard marks, 12th standard marks, BE percentage, the type of project he has carried on, type of skill he have, the certification if she or he has gone through, what kind of communication skill it has. Based on these features, they enable you to take a decision correctly. Without giving such information, by seeing the face of a student, suppose you don't know the student, by seeing the face of the student you can't predict. By seeing the roll number of the student, suppose the roll number is also given, the student roll number is also given, student roll number is also given, student name is also given. So the roll number and the name of student is not of the important feature. These are not a discriminative features to take such kind of decision. So you need to understand this terminology. What is the meaning of important feature? What is the meaning of useless feature? Useless features in terms of the given task are those that cannot contribute anything to take the decision. Roll number is not a parameter. The name is not a parameter that can help us decide to the quality of the student. But other parameters I have just listed over there. These are the parameter, features, and variable. So now everybody can understand how important the parameters. If you have a limited number of parameters, your model will not be going to perform well. I think this thing is clear to everybody. You can write on the chat box. If you have a very limited number of features variable, your model will not learn everything. I think everybody agree with this terminology, with this conclusion. You may write on everything on the chat box. It will make me uh, give me a lot of motivation. So I'm asking one question. If you have very limited number of features, yeah, thank you. So another, it doesn't make a sense if you have a lot of number of features that will help you a lot. It is also not true. You need to have a very good discriminative features only. So don't worry about that. If you have a 10 features, if you have a 10 features that are good, if you have a 20 features, if 20 features are not good or not important, even they're not going to help you a lot. So the important features are important. Yeah, Pooja have written something. Okay, another important part, I'm just opening up one dimension. I will not cover. I'm opening a dimension. How you will decide the features are given to you, which feature is important, which feature is not important. I'm just opening a one dimension that is called feature selection. So you may have a thousand of features and you don't have a domain knowledge. Like in this example, you have a domain knowledge. So if you don't have a domain knowledge, you can't understand the feature is important or not. You cannot randomly select it and go with the modeling. Then again, one dimension of the machine learning, one chapter, one course is there, the feature selection. We need to explore it. Okay, some of the algorithms in that part, like a principal component analysis, we will cover during the FDP, but all the things cannot be possible. But one dimension you need to understand. Okay, going ahead, in the data set, the features you got it normally in the data set. The if the data set is in the tabular format, so the column wise things, whatever visible to you, it normally call as a feature. Class labels. What is the class label? Class label means whatever the data set is given to you, here you can divide the feature in the two categories. It is a supervised learning. What is supervised and unsupervised I will cover. Suppose this is the variable 1, variable 2, variable 3, variable 4, variable 5, variable 6. So normally one of the variable, it is not necessarily be the last one. One of the variable you will consider as a target variable, or sometimes it is called class variable. Okay, or sometimes it is called output variable. output variable. The names intentionally I am just writing because you need to be familiar with that one. Target variable, class variable, output variable, and sometimes it is called a dependent variable. Dependent variable. And the remaining variable that you will use as a features to take the decision, it is called input variable or independent variable. Okay, why? Because based on that variable you will try to learn, you will try to predict something. So this is the output variable, means your target variable that you want to predict. It may be a target variable yes, no, it may be a cat, it may be a dog, whatever the things you want to predict. It may be a salary of particular person. Suppose you want to predict the salary of particular person, so it is a target. This target variable is depend on the set of input variable. Okay, so it is called the input variable. So the target variable, output variable, sometimes we will call it class variable. So now you try to connect yourself with this terminology. So for example, if such data set is given to you and the data set talk about the medical data where the age is given, gender is given, type of pain is given, blood pressure is given, cholesterol is given, and many things are given. And the last variable you have seen, it is a 0 1 0 1 0 1, means it is a target variable. 0 1s means that person has never been or never suffered from the heart stroke. One means he has suffered from the heart stroke. So here answer may be a yes or no, maybe 0 1, maybe true false. So this 0 1 means the things has been encoded. 0 means no, 1 means yes. So it is, the freedom is given to you. You may be using the word like yes or no, true false, the boolean things you can use, or you can encode it if you want by using 0 1. So the red color I have just rounded over there. It is output variable because that thing you want to output. Once the training will over, the patient will come. You will feed such kind of information, cholesterol, heart rate, and blood pressure, and the model will predict how much percentage of the chance the person is going to be suffered from the heart stroke, like that. Similarly, going ahead, I will not go in much detail. Type of data analytics. So there is a basically three subcategory you can define under the data analytics, like a descriptive data analytics, predictive data analytics, and the prescriptive data analytics. These are the words commonly used during the literature, during the books. If you try to study in various way, these words will be encountered. So descriptive analytics, very briefly I will go. So here, like here, you can see, I hope it is visible to everybody. Let me just, yeah. So descriptive data analytics is a branch of data analytics where it contains a set of procedures, set of method that used to describe your data. So something happened. Suppose you are running a business, suddenly you are facing some loss or gain. You need to know why it is happening. So the question why something happening, you need to analyze the pattern. You need to see the data, what happened in the history. So all such works that you want to perform, that comes under the descriptive data analytics. So what are the algorithms comes under the descriptive data analytics? That algorithm describe the data, like a clustering, like association rule mining, like all the visualization techniques, like bar chart, pie chart, bar chart, pie chart. So that you describe the data, the descriptive analytics, like that. I'm not going in the detail. Predictive data analytics means descriptive data analytics, unsupervised learning. So many of you are familiar with this word, the unsupervised learning. Unsupervised learning is a part of descriptive data analytics. Predictive data analytics, as name suggests, used to predict something. You used to forecast something, like a supervised learning. Like the example I have said, you need to develop a model that will predict the student will get job or not, will going to place. successfully in the placement drive or not. So here you want to predict something. The person will suffer from the heart stroke or not. The salary of the particular person. The flight will get delayed or not. Many things where you want to predict. You want to give the answer like that. So it comes under the predictive data analytics. All the supervised learnings comes under the predictive data analytics. Prescriptive data analytics, I'm not going in much detail. It is a mixture of predictive and prescriptive data analytics, descriptive data analytics. As you're supposed to know the name, prescriptive data analytics. With example, I can try to explain. In the predictive data analytics, you predict something. If you follow that prediction, what happen? I don't know. Prescriptive data analytics is one higher level of intelligence it contains. It does not give you one option like in the predictive data analytics. It gives you multiple options. And if you choose any one option, what may happen in the future, it also try to sense it. It also try to give you that sense. So it sometime will say that the prescriptive data analytics will suggest what you supposed to do, what you need to do. Like a chess game. In chess game, what happened? At the particular moment, you need to move. You have a lot of pieces. You have a lot of options. So if the computer is playing that game, so computer is supposed to know what is the benefit of selecting a one movement. There may be a lot of moves that you can have. You can move your pawn, you can move your knight, you can move your rook. Many options are there, or many way you can move. So in the computer or AI is designed in such a way it can give you a lot of options are there, and it will also suggest if you go with that options you are strengthening your situation or positions, or if you choose that move you are going to be lose your situations, you are going to be in a weaker section. So that type of situations normally we have seen in the game kind of software and area where the prescriptive data analytics have been used a lot. Going ahead, category of the machine learning algorithms. These are the words that many of the you, I hope, are very much familiar. So there are basically three category are there that you can assemble, you can categorize the various machine learning algorithms like unsupervised learning, supervised learning, reinforcement learning. So one by one, I will cover briefly. Unsupervised learning means, as the name suggests, there is nothing that can help you for the training and learning process. Like here, we have a one example I can see. If you have a target variable, if you have a target variable, during the training, you will try to predict something. And what your model is predicting, it match with the target variable. Target variable means true variable, correct answer. So whatever the model is predicting during the training, it is iterative process. It match with the target variable means you are going in the correct direction. But if the model prediction doesn't match with the target variable, correct answer, you need to do something. You need to change some parameters. So it is iterative process. So during training, it is a very much iterative process. A big data set will be given to you. You have to go multiple time scanning, multiple time scanning. Every time your model with every observation is predict something, match it. If okay, then very much. If it is wrong, you need to do something like that. So if here the target variable is giving to you, it is a kind of supervisor. It is a supervising your process and saying yes, no, correct, you are going in correct direction or not correct direction. So by which you can your process will be going on. It is very easy task. You know, easily you can check your model, you can check your direction, you can check your training direction. So this kind of process is called supervised learning. So where is some output variable will be given, and you have to match your prediction with the output variable. So that is called supervised learning. Under the supervised learning, there is another two subcategory: classification and the regression. Let me cover it. So under the supervised learning, there is a two part. You can say the classification, that is also a very famous word you might have known, and there is a regression. So it is totally, both the words are related to the target variable. Both are related with the target variable. If the target variable is a categorical variable, it is a class variable, then it is called classification. If the target variable have a numeric number or it is a real number, then it is called the regression. Suppose I want to predict yes or no. It is a category. Yes is a category, no is a category. I want to predict whether you are going to pass or fail. It is a category. Given image is a cat, dog image, or horse image. So you need to predict whether it is a cat, whether it is a dog, whether it is a horse. All are the categorical variable. All are the label. Sometimes it is called all are the label. So if such kind of data set is given to you, we call algorithm as a classification algorithms. We need to apply the classification type of algorithm classifier. Regression means suppose you want to predict the salary of a particular person, age of the particular person, okay, and return of your stock, whatever the stock, wherever you have invested, what will be the return. Such are the numbers, the continuous numbers. If such kind of problem is given, you need to apply the regression kind of algorithms. You cannot solve the such method by using any of the classifier. So that is a basic difference. Unsupervised learning, only one difference: they will not be given as a target variable, as output variable. No supervisor will be there. Answer is that some examples are there, like a clustering algorithms are there, and all dimensionality reduction method like a principal component analysis are there, and market basket analysis like a priori epi growth algorithms are there. That's a part of unsupervised learning. Reinforcement learning is a third kind of categories where the environment will be given, environment will be defined, environment will be very uncertain, and potentially complex environment will be there, and the agent, you need to develop an agent, and the goal will be given. Agent, or agent means model, or the algorithms. Agent have to fulfill the goal. As agent have to learn how to achieve the goal you have to define in that environment. Like a driverless car, a model will be there, and the task, the goal is given to that. You have to cross this traffic, you have to reach from this stage to this destination, and in between that environment, many people will be there, road will be there, moving objects will be there, turns will be there, blocks will be there, or breakers will be there, many things are there, and that is not fixed, it is a changing environment, and the agent has to learn how to achieve the goal. Like a robot you have designed, a robot have to follow some path. It is a reinforcement learning. And in the reinforcement learning, there's a two concept: reward and penalties. So agent have to start randomly moving, and based on the sequence of move he has to take, and based on its decision, if it is fulfilling, it is going to into the positive direction, that the objective function you need to define. If it is increasing the objective function, you need to award it. Award it means, yeah, you are in the correct way. If it is not helping to improve the objective function, you need to penalize it. So in every movement taken by The agent, you have to reward it either or penalize it. Reward it, penalize it until it reach the goal. So it is kind of reinforcement learning like that. I hope this much of a small discussion is okay for developing the fundamental concept. Uh, that thing is cover supervised learning applications, unsupervised learning applications are there, reinforcement learning applications are there. So that we don't need to discuss about that. Now, I just need to take upon a discussion of training and testing data. So what happened in the training and testing? So you need to understand so that we can go for the implementation. Well, primary objective of the machine learning is that to develop a model. Once model is developed, it can take a decision behalf of you, and you don't know what is the solution of that problem. That's why machine learning you required. Otherwise, conventional programming is also there. Why we need the machine learning? Okay, one very good idea. Okay, so many of the time when I ask questions, why we need machine learning? Why need the machine learning? Ask this question to yourself. Why we need the machine learning? We have a conventional we have a conventional programming. We know the conventional programming versus machine learning programming. That is a very, very, very important thing you need to understand. Conventional programming, like that the programming you already have experience in where like data structure programming, web development programming. What kind of programming till date by using Java, by using C, by using C++, we have done till date is a kind of conventional programming. One is the machine learning programming. Why we need the machine learning? We can solve it by the way we used to do programming in many years. So somebody is writing correct answer, the learn on their own way. So if one way, if I can answer, if you know the solution, if you have the solution, then always go with the conventional programming. Whatever the problem is given to you, that question is then okay. Okay, if I ask the question, how do you know when you should apply the conventional programming and machine learning programming? You are independent freelancer. I am the client. I don't know what is machine learning. I have given the task. So this is I want to do. You do it. How do you know whether you should choose the conventional programming or you should go with the machine learning programming? You have mastery now the tool, but you don't know where you're supposed to use that tool. It is a basic problem. So whatever the problem is given to you, if you know the solution of that problem, thumb rule I am talking about, go with the conventional programming. There is a no other better solution in the world than the conventional programming, because the conventional programming don't have any error. It is 100% accuracy. If you write a program of addition of two number, you write a program, it will never give the wrong answer. If you write a program of factorial, calculate the factorial number, it will never give the wrong answer. Conventional programming having 100% accuracy. But if you don't have the solution, you cannot write the code. Then you have to go with the ML programming. That is the thumb rule. If really you wish to have a complete lecture on this topic, I may conduct. I will try to change the some schedule. I will try to introduce that lecture where with this small example we may see what is the typical difference with the conventional programming and machine learning programming. What kind of problems are there that you can categorize here and there, like that we can cover if you wish it. Otherwise, going ahead. So what happened in the training and testing? Let me explain. In the training, the data set is given to you. I'm talking about the training testing with respect to the supervised learning, with respect to the supervised learning. So data set is given to you. The data set is given to you. This is the input variable. This is the output variable. Suppose this is the output variable or this is the correct answer. And this is the input. So during the training, what happened? The training data set I am talking about. Training data set. During the training. Because during the training, we use the training data set. The during training set, we provide data plus correct answer. Plus correct answer. Means the data set contain all the input variable plus output variable also. So that algorithm will try to map the data. By using the data, they can make the prediction and try to match the prediction with the correct answer. It is keep on iterative process, iterative process, iterative process. And what happened in the testing or evaluation? Test data. We provide only the data. We don't provide the correct answer. In the data set, we have to make the such changes. So what happened? If learning process is over, we provide the data and algorithm will predict something. Algorithm predicted this one, this one, this one. Then separately we match with the correct answer. We have a correct answer, don't worry about that, but we don't feed during the testing. We feed only data and algorithm have to predict. Then we match it, how well it is performing, how well it is performing. Accuracy sometimes we'll call. What is accuracy? If it is 100 observations are there in the testing, out of 100, 90 observations it has correctly classified or correctly predicted. So testing purpose is to evaluate the model. Training purpose is to train the model. It is a learning purpose, learning oriented. Going ahead, the things are written over there. So normally what happened, it is not a thumb rule, don't worry about that. Whatever the data set is giving to you, around 70%, 75%, sometime 80% data are divided, split, make a training data. Remaining 30 or 25 or 20% data become a test data. The whole data set will be given to you. You have to split the data. 70, 80, 75, it is a thumb rule. So, but number is like that, it between 70 to 80%. You can keep for the training purpose because learning required more data, more practice. The answer is that why the training data, major part of the data set should be designated as a training data because training means learning. Months required for teaching a student, we require a full semester. So more data, more variety of variable, more iteration, more scanning, the algorithm will learn nicely. Testing data means a small number of test data you can feed and check the performance of your model. Uh, Anurag Jain is asking, please provide the WhatsApp link to join. 50 times I have shared that links through the email. If you have given Anuragji correct mail ID in the registration, you might have received my mail. So please go through your email, check, and you will join through that mail ID, through that link. The link has already been shared multiple times. You don't write the mail over here. I'm not going to send anything. I have sent already. If you have provided the correct email ID, the mail will be there. So you will check your registration plus, please. The type of attributes. So type of attributes means type of variables, type of features. So there are various kind of features are there. Basically here I will focus on three type of variables. Variables may be a categorical or nominal. Variable may be ordinal. Variable may be continuous. So let me explain the difference between categorical, ordinal and continuous variable. Categorical variable means already we have seen there is a category like male and female. So suppose in the data set gender. Gender is a categorical variable it may have a sub-label male and female. Okay, like a hair color, black hair color, brown hair color, red hair color. It is a category. One thing you need to understand, it's a categorical variable or nominal variable, both are the same name. Whatever the sub-labels are there, you cannot see any intrinsic ordering between the labels. So you cannot say the female is number one, female is number two, or a male is number two. Black or brown, red hairs are the labels of the hair color. So you cannot arrange in order that can convey some meaning. It is a category, but you cannot convey some meaning by arranging here and there. You cannot sort it. Agree? So if you cannot make a arrange like a highest to lowest, lowest to highest, so please see, it is a case of categorical nominal variable. Another one change is that if it looks like it is a category, but there is an intrinsic order among the labels, then it is called ordinal variable. So one is a categorical variable, another is ordinal variable. Like economic status, suppose in the data set economic status, somebody is from low economic status, medium or high, you can arrange it. It's a low, medium, high, it has a meaning, it has some meaning. Okay, like a feedback, happy, not happy, so happy, you can arrange in some order. Like a feedback, you give 1 star, 2 star, 3 star, 4 star, feedback. I'm happy, not happy. And when you go for the Amazon.com, you purchase something, then you give the feedback stars. Star is the ordinal variable because it is a meaning. In order you can arrange 1 star, 2 star, 3 star. So that is a one basic difference between ordinal variable and categorical variable. Like with the example, you understand what is your gender, it is a categorical variable. What is your hair color, it is a categorical variable. Where do you live, North India, South India, East India, it is a categorical variable. But if I ask how do you feel today, very happy, unhappy, happy, okay, happy, very happy, it is an ordinal variable. Satisfied, not satisfied, such kind of things, it is an ordinal variable. Third kind of feature may be a continuous feature, means it will be a number like a age, salary. It will have a real number, maybe integer type, maybe floating point type, it doesn't matter. So it is called continuous variable. Okay, going ahead. Now I will demonstrate how to import the data into the R environment very quickly. So let me explain about very briefly about normally throughout the FDP, some of the resource person may use the R, some may use the Python, and very few will use the MATLAB. Reason is that it is a free, it is a open source, it is a free language. So I think 99.99% market of the data science and machine learning covered by the Python. It is a free source. I'm not going to discuss which is better, which is not better. Both the languages are in high demand. A lot of jobs, a lot of career options are there. So R I'm going to use by using the editor R Studio. Like a Python, if you are know, like a Jupyter, like a Anaconda, like a Spider. These are the editor. So editor will enable you to perform the programming. Similarly, R is a language. It is a 30 or 40 years old language, and R Studio is an editor that enable your programming. So how to you just Google it or type the R Studio. So like if it is visible, I can show you. You type the R Studio. So it is already there. Otherwise, Google it. It will come directly. Let me type over there. You can understand R Studio. So R Studio you see over there. download the RStudio. The moment you will go over there, a lot of options are there like this. You want to install for the Windows, Mac, Ubuntu, Fedora, and many type of operating systems are there. Based on your operating system, you can download the RStudio. It is an exe file. You just download it, click it. Don't worry about anything. It automatically install. The simplest way of installing the software that you might have seen till date, it is one of them. And you might have observed the size is 156 MB or allowed 200 MB. So many of the student and participant having misconception for a machine learning or data science, you require a lot of uh, 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 computational power. No, a simple laptop or system you have, you can just download it. It's super duper powerful, and you can start your learning. So here I have installed. I'm going to just open the RStudio. Just RStudio. I'm going to open it. I will not discuss much about the editor. What minimal thing is required, I will explain. Okay. So you see, the editor is visual to you. A lot of things are there: file, edit, code, plot. Many things are there. It is not right time to discuss. Discuss is there. This is the portion is given to you. You need to write the code. I will write all the code over here. Whatever the code you want, you can write. Okay. And the moment you will enter the command, the output will be appear in the next line. Okay. So that is the way where you write the code. And if the output is an image format or video format or any visual way, so output will appear in the right hand side, this right hand side window. Okay. So that is a minimal thing is required. We are starting with this minimal understanding. Going ahead, two simple command: get wd and set wd. Why get wd means get working directory, set wd means set working directory. So what happened? What is the meaning of working directory or root directory? It is optional things. If you don't want to go with that, don't go. So optional things talk about, like in the data science and machine learning projects, you need to access your data set multiple times, or you may be working with a multiple data set. So every time when you need to upload or import your data into the R environment, you need to write the complete path wherein the system dataset is there. So there is a two options, which is by default the root directory. You save your dataset over there, because the thumb rule is that if the stuff in the root directory are already saved in the root directory, you can directly access those stuff without writing the whole URL, whole path. But if your dataset is somewhere else other than the root directory, you need to write the complete path. So either you copy your dataset into the one location. Technically it is okay, but it is not feasible, because you might be working with variety of dataset, maybe in GBs and TB, and storing all the dataset into one location is very difficult. So another way is that where is the data set, that folder you make as a root directory. So that's I'm going to demonstrate how to do it. So in this way, first check what is my uh, uh, sorry, working directory. C users HP document is my by default working directory. You can keep all the things over here. Otherwise, you can change it. So how to change it? First, where is my data? So suppose this insurance. Insurance is my data. This is a CSV file, suppose. Okay. So that file I want to upload. So my file is over here. So this is a complete path is there. I'm going to copy. Okay, using the set wd command, double quote, you just copy that path, make all the backslash because it is a part of syntax. I don't have any logic to explain. Enter it, again check, get wd. My path successfully changed. My working directory changed. One, the command, two command we have seen, the get wd and set wd. Very briefly, small things I will cover, will not go in much detail. How to import the data into the R environment. First, there may be a variety of data. Data may be in text format, data may be a CSV format, data may be a video, data may be audio, data may be a JSON file, data may be XML file, data may be XML file. Whatever the data type is available in the world, R and Python are enough to handle those data. Based on the data, different predefined functions are there. So keep the discussion very minimal and don't try to create the confusion. Suppose we have a CSV file, comma separated file like this. This insurance.csv is a file, and I have opened the file having a data set with the feature age, gender, BMI, children, smoker, region, expenses. I want to import that data into the my R environment. How can I do it? So for a simplicity, consider one predefined function is already with the R read.csv. Name is very simple, read.csv. You call that function and you pass the file name if that file is in the root directory. Otherwise, you can pass the complete path. In the both way it will work. So the read.csv, the function, file name is this one. I am just importing and going to store in one variable. This variable name is up to you, whatever you want to give. A, B, D, X, Y, Z, whatever you want. So let me copy that command. So you see, please observe over there. I'm just going to paste it. You can also use the double sign. Okay. So it is a variable name, read.csv, the function, and this data I want to import into the R environment. Within a second, it has uploaded into the R environment. There is no error. I want to see whether successfully it is in my session or not. You just copy and paste that variable name and just enter it. You see, the whole data is here. Age, gender, BMI, children, smoker, region, expenses, whole data set is there. So that is the simplest way to upload your data into the R environment. Similarly, if the data set is not in your system, maybe in some server, or maybe through the internet link you want to import, that also work. So whole path you can give. The read.csv is enough capable to access the data through the internet. So that you can do it. I'm not going to demonstrate. So whatever the data here, you can just import into the R environment. Oh, somebody is writing, I'm not audible and the screen is stopped. Other participant, please give your feedback. My screen is visible or I am audible.
Yes, sir. Yes, sir. You are
Okay,
visible
thank
and
you.
audible.
Very thank you. Other participant, unluckily, if facing any problem, please check your system. Thank you.
Audible, sir.
Thank you. Thank you. Right, library. You might have listened the name library. You need to install the library in Python or MATLAB or in the R. In the R library is normally we call it package. So based on the problem you are working, based on the data set you are working, various kind of algorithms you need to work with that one. So you need to install, you need to explore the libraries or package accordingly. So sometime in the C it is called header files. So you include the header files, predefined things are there, ready to use it. Similarly, package or libraries are there. So thousands of libraries, thousands of packages are there, and every package are designed for their own purpose. You can design your own package, you can contribute your own data set in the form of package. So these packages do not only contain the functions, it also contain the data set. There are many packages that provide the data set. You use that package, use that data set that's are inbuilt in that package. So package are there. Suppose you want to work with the regression, you have to use the regression package. You want to work with the deep learning, you have to use the CNN packages, RNN packages, and many. PyTorch is also kind of package. Okay, TensorFlow is a kind of package. Okay, so many things are there. Based on the requirement, the appropriate package or library function you have to download. How to download, how to install it? There is two phase. Install.package is a command. In the bracket, you have to pass the package name. So that information you're supposed to know in advance. Which package you want to install, which header file you want to install. If you don't know the header file name, it is not possible to include it. Similarly, package knowledge will be advanced, you're supposed to know. Once you enter that command, the package will install for you. And it is the command install.packages will list you all the packages that already installed. Suppose I'm going to run that command. You see, install.packages, these are the sub packages already in my R environment. So many packages are there, so many are there. So it will list you like that. ggplot2 like that, gdata, glue, gmodels, gtools, many packages are there, so that you can see it. The most important thing is that or one more thing, you if the package is not in use, and then you can remove, simple install that, remove the package name. The most important part is that this command, once you install the package, I'm again repeating, once you install the package successfully, it doesn't mean it is available for you. Installation is one phase, and another phase is that including that package into the session. So session means where at the time you are working. So all the packages already installed on your system means it will not be available for you until you include them by using the library function. So this library command purposefully, intentionally, explicitly you have to call. So okay, one package you have installed, very good. Then call that package, include that package by using the library command. Then all those functionality will be available for you. Okay, going ahead, uh, mm, about the data conversion, I'm talking about a very important part. So suppose that command you are familiar, the .read.csv command is there. I'm going to upload my data, and the variable name is the insurance I have given. My data is there. Another command is this str command is used to give information or detail about your data set, data type detail you can say. So insurance is the data you have uploaded in this variable. You pass this as a parameter into the str command, and you will see what happened. Yeah, there are 1333 observations like that. There is this number of rows. Okay, 1 2 3 4 5 6 7. 7 variables are there. First is age, type of variable integer. Second is gender, type of variable character. BMI is a number, means here number, here integer means integer number, number means floating point number. Children is an integer, smoker region as a character and character. So if I ask the question, which is the categorical or which is the continuous variable? So easily you can answer this integer and this number means age and BMI, and expenses is a continuous variable because these are the numbers. These are the numbers. That is a continuous variable. where the gender is a categorical variable. Smoker is a categorical variable, whether yes or no. Reason which part of country you belong is categorical variable. But you have seen here it is saying the character. Character is not a categorical variable. Character means uh, uh, it will consider FEMALE as a combination of the ASCII value. And similarly, the male, the algorithm during the training will not consider the male and female are two category. They are not sequence of character, they are category. So that is a big problem. By default, the things are there. The system will consider as a character. They will not consider as a categorical variable. So how to convert? How should I inform to the algorithm? Don't consider as a character. Consider as a categorical variable. Okay. So one way you can also check it. Uh, okay. How to access the particular column? Let me explain. So when I type the insurance, the whole data set will be visible to you. I don't want that. I want a particular column. So you use this dollar sign and all the columns will be visible. Which particular column you want to access? Suppose this I want to access. You see, agree? So you can also check whether the given feature and column is a categorical variable or not. You can see the labels. By default, as a domain knowledge, you can understand this gender is a variable having a two labels, male and female. Programmatically, can I check it? Yes, label is already a predefined function. You pass a column name. If the column is a categorical variable, it will find the unique name, male and female, and how many number of unique labels are there. So let me copy that command and will paste for you. Null means there is no labels are there. It is visible to you as a human knowledge because you have a human knowledge. But as a computer is not a human, so they can't understand the gender is a male or female or region. You can also call if you want. No, same answer. So I need to do something. So how to convert? So this is a factor. Factor is a function. Categorical variable also sometimes called the factor. So I need to call a factor. I need to pass that column that is a character type of column and I want to see as a categorical variable. So factor function will convert as a categorical variable and save in the same as it is going to replace it. Convert into factorial variable. So let me copy it again. Okay. If it's successfully converted, then let me run that command and you will see. Yeah. Now same command I am running over here, the same command I am running over here. It was not a categorical variable, that's why there were no labels. Now explicitly I have converted the variable as a categorical variable. Now it's saying it is a category. It is male, female is a one category, male is a one category. Okay. Now you can check it in another way. Earlier we have seen. You see, now this gender is a factor with two labels, female and male, and are automatically encoded female with 1 and male with 2. You can also change it programmatically by way you want to encode. You can denote 0 for the female and male for the 1 like that. By default, it is like that. For a computer, it is very easy to work with the numeric number. That's why for the performance enhancement, the categorical variable labels are automatically be encoded in the numeric number like 1, 2, 0, 1 like that. Others are not, like smoker regions are not. Okay. So in the one way I want to convert. So all the character variable I want to convert in one way. So during data import, you can do one thing, like the same command I am writing read.csv, that file I want to import. You pass one parameter, whatever the strings are there. String means characters are there. String as a factor, true. By default, it is false. You can consider as a true. So now let me import my whole data set again by passing the one variable string as a factor true. You see, is successfully uploaded, and let me check the property. All are factors. What were the character string variables were there? It is converted into the factor. Now you see the region having four labels: 1, 2, 3, 4, like that. Very important part you need to understand. What is the timing? 11 o'clock. Time is over. Okay. One command I want to like a table is a command. Suppose the question is given to you, okay, the gender is a category, so how many observations are belongs to the female and how many are belongs to the male? Like that you can answer how many are a smoker, how many are not a smoker. So the table command is there, you pass the column name only, whatever the things are there in the different level, it will calculate and will give you answer like that. This region having a four label: 324, 325, 364, or 325 are the observations to particular level. You can pass this. You see 662 are the females and 672 are the male. So by this way you can also check whether your data is imbalanced or not. You might have listened that word, data imbalancing problem. So these things you can also check. uh should I okay. Hmm. I think it is okay. Time is over, and I will cover how to split the data into the next session. 1 minute. Let me make one announcement. Next lecture, as the per timetable, as per the schedule I have shared with you, it is going the same way. And there's one great personality I have invited, the Vivek Bansal ji, I think from the Uttarakhand. He is going to talk about the mental and emotional strength, uh, uh, how to improve it, how to control it, because nowadays, because of pandemic, because of work pressure, and many reasons may be there around us, we are suffering from uh, mental illness. We are not much strong mentally or emotionally. So it is a compulsion and instruction given by the AICTE or ATAL sponsored workshop, sponsored agency. One lecture must be based on the yoga, mental strength, mindfulness, and many things are there. So that's why I try to keep such kind of talk in the first day of the FDP. So the next session is going to be a that part. This is small announcement. Now, any of the question you have, I'm going to open the discussion forum. The next session we will start from 11:45. Please be focused on the time. I may float the attendance in the next session or maybe in the next to next session. So timing is so important. I will not waste your time at all. As the timetable we have started our today class. Similarly, I request to everybody be punctual, be available on the time. Okay, so the question answer session is open. You may write your questions on the chat box or either you can unmute and ask, please. I'm audible to everybody. Okay, so any if feature no no. One question is there, if features are the same as a hyperparameter, no. Features are the part of data set, hyperparameter part of algorithm. Totally both are different. Hyperparameter or coefficient is a part of algorithms. Algorithm may have some set of parameter coefficient. So feature is a part of data set. Both are different. Is it okay? Okay. Any, or you can share your feedback from the day one. If I'm going a little bit faster way, you can say, sir, go with the slow. If I'm slow, you can give your feedback, cover the topic in rapid way. I can change my pace according to your feedback. It is also important whatever the things you feel you share, don't make this FDP too formal. Okay, so the flexibility is given to you like that.
Good morning, sir. Am I
Good morning.
audible? Sir, I
Yeah,
don't
please.
get the chat box here to type the messages. What is the
No,
reason?
everybody is writing. Everybody is writing. Everybody. Most of
I
the.
don't know. I joined as
So
guest, I think so.
I can't control your system, so I can't see what
Okay.
is the problem. You have to
Okay.
you have to see it.
So I can rejoin it again?
Maybe,
Oh,
maybe,
yes, sir.
maybe. The next question somebody have written: can we copy the feature from the dataset to the hyperparameter? No. There may be 10,000 hyperparameter. You may have a three feature. How can you copy it? During the learning process, the algorithm will estimate the value of hyperparameter. So you cannot copy it.
Good morning, sir.
Good morning.
Sir,
Yes, please.
in for the machine data. Hello?
Yeah, please.
Sir, the input for the machine learning is data, but organizations are very much reluctant in sharing the data. How can we deal with this problem?
That is not our problem. If you have a data and you have a data scientist or machine learning expert, you can do it. Otherwise, there is no any machine learning algorithm I have that we can use to forcefully take the data from the organizations. I cannot
Sir,
take any for I can't arrange the data forcefully. Ultimately, you require the data. That is your smartness, how you are requesting for the data, how you are approaching it. That is a totally different segment. Got it, my answer?
sir, my confusion here is that if we want to develop some machine learning algorithm and we want to
For
machine to
whom?
learn
For whom?
for, for certain
For whom?
applications, sir,
Certain
say for
application means, wait, one by one. The answer will be there in my questions. Certain application means somebody will give you the task to do it. That is called applications.
okay.
Yes? Yes or no?
Sir, for example, I am developing some applications to predict a particular disease. But at the same time, the health organization are the people working there. They
Yeah,
may be
my
learning.
question is there. My question is there. In the real life, somebody will give you task as a client. Develop this model. I am the hospital person to develop that model for me. The hospital have to provide the data to you. Why you are developing for that? Those hospitals who are not going to share your data. Now the question is the research purpose. If you want to do something, question is the
Okay.
research purpose. In the research purpose, there are many data set openly available. Like in the COVID, pneumonia data set is available where the chest or skin data set are there. Brain data set is there. Openly available, a lot of data sets are there. Crores of data set are there that is medically oriented. Use that data. What is the problem?
Thank you, sir. Thank you.
But if you want to use only that data, or the data is not available, then it's unsolvable problem.
Thank you, sir.
Okay, thank you. Any other question? Arjit ji is asking, please explain the prescriptive data analytics. So, prescriptive data analytics is something, sir, I can't control or I should not explain right now because you require the total basic understanding the predictive, prescriptive, and reinforcement learning so that I can explain properly about the prescriptive data analytics. But what is the minimum information, minimum knowledge required of prescriptive data analytics? I already covered. So all that recording will be there. All the sessions are being recorded, and after 5 days, it will be available to you. I can also share, or the AICT will also share with you. I have to upload all those data set to the AICT. So please revisit that discussion to make it clear. Yes, it is a mix of predictive and descriptive data analytics, you can say. Prescriptive is very modern kind of data analytics. I think it is not, first session is not the right time to discuss about the prescriptive data analytics. If you remind me, I can take up that discussion at the last day of the FDP. So please remind me at that time. Throughout the 5 days, you will develop that understanding so that can understand what I will try to explain. So first day, it is not right time to properly explain about the prescriptive data. These are the terminological terms purposefully I have coined today so that you're supposed to know these are the terminologies only and basic understanding. Any other question, feedback, anything? The way I am just covering the session, it is okay, or should I speed up or slow down? That you can also explain, also share like that. Okay, then we are going to have a almost 30-minute gap. Thank you for your comment, and I request to join before 11:45.
Thank you, sir.
So I'm thank you. So we will again start our second session 11:45. Request to join before 5 to 10 minutes before. Thank you.